Structure and bonding of element and compound, Part 1. This two-part video explains why there are only 4 possible structures that form when elements bond: molecular covalent, chain covalent, metallic, and ionic bonding. If you want to know more about each individual bond, you can click on this video. Atom bond if there is space in the outer electron shell for more electrons. Thus, the noble gas with their full outer shell don't easily form bonds. In an atom, the inner complete shell of negatively charged electrons are held tightly by the positively charged electron in the nucleus.
However, the inner electron will receive some of this nuclear strength from the electron in the outer shell. We will only feel this electron, thus in growing in the chain electron will cancel out or neutralize the effect of chain of proton. So the outer 7 electron feel an effect chain of just 7 blood, holding them in the outer shell. Outer shell sodium will 11 and 11 electron has also 10 in electron leaving an effect chain of only blood want to hold its single outer electron. The Vichy white nanometal with nearly full shell hold onto their electron more strongly than metallic elements with nearly empty shell. We also see what upon if there is a space in the outer shell electron from the outer can be attracted in by this effect. Nuclear chain bursts only until the shell is full.
So let's start with the periodic table of elements omitting the naphtha and this lateral of radioactive element. From our periodic table, naphtha hydrogen with each have few cells of electron. Here graphite equals being group 1 with each 1 outer electron and group 7 with 1 electron mixing. Here on the very reactive metal like potassium. Here on the very reactive non-metal like oxygen and chlorine. In between, the element crystallically change from being metallic to non-metallic with some like silicon and germanium, neither one nor another.
If we trace the periodic table clockwise and then swatch each flat, we pretty much have the elements arranged from the most metallic cesium to the most non-metallic fluorine. When these two extremely elements react, they form the stable white salt cesium fluoride. We now have a triangular space where all other combinations of elements can be situated. Elements are along the top, and the space will be filled with compounds like brass, sulfur dioxide, sand, and salt. By considering the reaction between pairs of elements like this, we will show in part 2 of this video that there are 4 types of bonding possible.